Hi. So let's do some problems in real analysis, in particular metric spaces. So, okay. I'm gonna open up my Paint app first. There we go. So first, we want to show that the real number line, okay, both the set of all real numbers and the empty set are both closed and open. And so this is really obvious. You can show that so you just define the metric space to be R first, and so then we will have R C equals empty set, and so you just have to show that this is closed because it contains its own limit points, which is no limit points at all, and so it is by it's just true. It cannot be false, rather. And open set, you want to show that it is an open set, so you want to show that there exists some epsilon greater than 0 such that VE of X is this, what's how that it for all X element null set. But given that null set is null set, yeah, so therefore question 1 is just basic, and like obviously this is correct. Now yeah, is A closed? Is A a closed set? Well, then we ask, does A contain its own limit points? Okay, but we can pretty easily construct a sequence. We can pretty easily construct a sequence of irrational numbers. We can have something like a root 1 over n dot n is n. Okay, can choose a sequence a n is defined by this intersect with I. Like, okay, this is not very formal, but you can just do something like that. Yeah, this is not that deep, bro. Wait, what's how? So arbitrary union and finite intersections of open sets are open. So okay, so let's just do finite intersection first, right? So finite intersection, then we can just select a min. We know that for every, you know what, I'm just gonna be nice. I'm gonna write the whole thing down, and no one's gonna watch it, and it's gonna be a waste of time. But I love math, so there we go. Oh, you guys should start. You guys should read this really cool thing called Discourse on Inequality by this fella right here. It's really cool. Anyways, finite intersection of open sets are open. So you have something like that, right? Okay, so all of these here are open set, which means that for all X element of a n ai, I is between 1 and n. So for all that, there exists there exists an epsilon I bigger than 0 such that my brain is dying for some reason, but of course this is very easy. Okay, we can use V to denote it, we can use N to denote it, we can use NR instead of N epsilon, we can use like B epsilon, like just use anything you want, bro. And X. So this is the VEIX. Oops, sorry. R. Where were we? Where are we? Where are we? Happy birthday, Singapore. But where are we? Oh, okay. It's AI. Yeah. AI. Just a moist critical reference. Yeah, so that's it. So then you just let epsilon equal to the, you just give me a while, my computer's a bit slow. You just set epsilon of I equal not epsilon of I, epsilon equals to minimum of all these epsilons and then suppose the finite intersection is empty. Okay, if it is empty, then we know that this is open and we are done. So then what if it is non-empty? So we consider the intersection to be non-empty, right? And that means that intersection N I equals to 1 AI that simply means that if X is an element of this, then X is an element of all of this from 1 to N, right? And so that means that if we let it be the smallest possible epsilon, we let the epsilon be the smallest possible epsilon of all of these combined epsilon, what we can then do is we can have a ball that contains X, that we know for sure contains X, and it is inside the intersection of all the this is bad because this one is the smallest, right? It's the smallest epsilon possible, right? So that means it will just work. It's not formal, but I mean it's good enough, bro. If you want formal, just like give me like paper. That'll make this all so much simpler. We're only 3 questions in and I'm already cooked. I mean, arbitrary union isn't that obvious enough? Maybe not. Okay, maybe it's not. So then it's like an open cover. Do we use A? Sure. A lambda such that lambda is an element of a set, because it's arbitrary, it doesn't necessarily start from 1, and so we just denote the union as lambda So let X be an element of this horrendous drawing. X be an element of this horrendous drawing, and since we know that this is all open, so now, okay, I mean, just recall the definition of open, I guess. It's really not that deep. I think it's dinner time or something. Okay, let's finish this. So X is an element of the union, which means X is an element of a lambda 0 for some lambda 0 as an element of a, not a, like the weird omega thing here, yeah. For some, okay, you know what, I'll draw it nicely, okay? I'll draw it nicely. Yeah. So what does that mean if X is an element of this? This means that our epsilon, this one, works for X is a subset of A, and this is a subset of this, and we are done. And something about De Moivre's. Yeah. And yeah, just De Moivre's, bro. Okay, is subset if only if it's a union of a commutable collection of a so open. Okay, so this is an if and only if, right? Well, do open imply A is the union of countable collection of open interval. Open imply A is the union of a countable collection of open intervals. If it's a countable collection of an open interval. Okay, first we know that the open interval is obviously an open is an open set. So the second, the backwards is just by problem 10.3, and the forward open if that okay, open imply that, open imply if it's open it implies, I'm pretty sure you just use the v epsilon x definition and just do some funny manipulation, and then it will somehow work out. And if it doesn't, just prove by contradiction. I'm sure that'll be fine. Anyways, I'm gonna eat. Goodbye.